From the towering pines of America's forests to the precision of modern sawmills, we're about to witness an incredible transformation. Today on Global Works TV, we'll take you inside the world's most advanced lumber operations, where million-dollar machinery meets generations of craftsmanship. Get ready for a journey through wood processing like you've never seen before. You know, there's something timeless about the sound of a chainsaw echoing through the forest. For generations, America's lumber industry has been built on the backs of skilled loggers who understood that harvesting timber is both an art and a science. Today, we're taking you on a journey that begins high up on these steep mountain slopes, where modern technology meets old-world craftsmanship. What you're seeing here is a carefully orchestrated operation. These aren't just tree cutters. These are forest technicians with decades of experience. Each tree is evaluated for its species, age, and quality before the first cut is made. The chainsaw operator you're watching has likely been doing this for 20 or 30 years, and he can tell you everything about a tree just by looking at its bark and listening to the sound his saw makes as it cuts through the wood. Now, here comes the really impressive part. Once these massive logs are cut, they can weigh anywhere from 2 to 8 tons each. Getting them down these steep hillsides used to require teams of horses or oxen, a process that could take days and was incredibly dangerous. But modern cable logging systems have revolutionized this process. Then as these logs reach the landing zone, you'll notice the methodical way they're sorted and loaded. Each log is marked with paint codes that tell the mill operators exactly what species it is, when it was cut, and where it came from. This traceability has been part of responsible forestry for over 50 years, ensuring that every piece of wood can be tracked from forest to final product. Welcome to a modern American sawmill, where tradition meets cutting-edge technology. What you're looking at represents over a century of evolution in wood processing. These facilities process millions of board feet of lumber every year, and the precision required is absolutely remarkable. At the heart of this operation is something that would have seemed like science fiction to the sawmill workers of the 1950s, the Medetec tunnel detection system. This isn't just a fancy sorting machine, it's essentially giving each log a complete medical examination before it's processed. NTHE Medetec system uses a combination of X-ray technology, laser scanning, and computer analysis to peer inside each log. As logs pass through this tunnel at speeds of up to 600 feet per minute, the system creates a detailed three-dimensional map of the interior. It can detect knots, grain patterns, moisture content, and even internal defects that would be invisible to the human eye. What makes this particularly fascinating is how it connects to the mill's optimization software. The system doesn't just identify what's inside the log, it actually calculates the most profitable way to cut it. Should this log become 2x4s, 2x6s? Maybe it's perfect for high-grade appearance lumber? The computer makes these decisions in milliseconds, maximizing the value extracted from every single log. You'll notice how the logs are automatically sorted into different lanes after passing through the detector. Each lane represents a different processing path, with logs grouped by size, species, and intended end product. This level of automation allows the mill to process logs 24 hours a day with incredible consistency. NTHE old-timers who worked in mills 40 years ago would recognize the basic process, but they'd be amazed by the precision and speed of today's operations. Back then, sorting was done by experienced graders, who could evaluate a log with just a quick visual inspection. Today's technology builds on that human expertise, but adds a level of detail that's simply impossible to achieve with the naked eye. Greentree Forest Products represents the pinnacle of modern sawmill engineering, where every piece of equipment is designed to work in perfect harmony with every other component. What you're about to see is a fully integrated production line that can transform raw logs into finished lumber with remarkable efficiency and precision. Let's start with the Mellott Extra Heavy Duty LMR 48-inch debarker. This machine is built like a tank, designed to handle logs up to 4 feet in diameter while removing bark with surgical precision. The 48-inch measurement refers to the maximum log diameter it can process, and those rotating arms you see are equipped with carbide-tipped tools that adjust automatically to each log's contours. NTHE genius of this debarker lies in its ability to remove just the bark while preserving every possible bit of valuable wood fiber. The hydraulic arms apply exactly the right amount of pressure, enough to strip away bark and debris, but gentle enough to avoid gouging the valuable wood underneath. This precision matters because even a quarter inch of unnecessary removal across thousands of logs adds up to significant losses. You know, the evolution of debarking technology tells a fascinating story about American ingenuity. Back in the 1920s, most mills used what were called rosser heads, essentially large grinding wheels with protruding knives that scraped bark off logs. These early machines were incredibly wasteful, often removing up to half an inch of good wood along with the bark. The The Mellott Company, founded in 1946 by John Mellott in Pennsylvania, revolutionized this process by developing hydraulic ring debarkers that could follow the natural contours of each log. What's remarkable is that John Mellott was actually a blacksmith who started making sawmill equipment in his barn after World War II. His innovations in hydraulic pressure control came from his experience working on military equipment during the war. Today's Mellott debarkers can process logs at speeds of up to 200 feet per minute while removing bark layers as thin as 3/16 of an inch, a level of precision that would have seemed impossible to those early mill workers. NTHEWDH 120 log trough is where the magic of modern sawmill engineering really shows. This trough guides debarked logs to the head saw with incredible precision. The V-shaped design cradles each log, while hydraulic dogs, those mechanical grips you see, hold the log securely in position. What's remarkable is how the trough can accommodate logs ranging from 8 inches to 4 feet in diameter without any manual adjustments. Now we come to one of the most impressive pieces of equipment in the entire operation. The Mellott bark removal system, with its heavy-duty vibrating conveyor feeding into the troughing idler belt conveyor. This system handles one of the biggest challenges in any sawmill, dealing with the massive amount of bark and debris that comes off the logs. NTHE vibrating conveyor operates at a frequency designed to separate bark chips from valuable wood chips. The vibration causes the lighter bark material to move in one direction, while the heavier wood particles move in another. And this bark removal technology has deep roots in American manufacturing history. During the Great Depression, sawmill operators discovered they could sell bark to paper mills as a fiber source, turning what was once considered waste into profit. The challenge was separating clean bark from wood chips efficiently. Early separation methods relied on screens and air systems that were notoriously unreliable. The breakthrough came in the 1950s when mining equipment manufacturers began adapting their ore separation technologies for sawmill use. Vibrating conveyors, originally designed to separate different grades of coal, proved perfect for sorting wood materials. The frequency you see here, typically between 901 and 200 vibrations per minute, creates what engineers call differential particle movement. Lighter bark particles essentially bounce along the surface, while heavier wood chips follow a different trajectory. This technology was so revolutionary that by 1965, virtually every major sawmill in America had converted to vibrating separation systems. Today's advanced systems can achieve separation rates of 95% purity, meaning that wood chip byproducts are clean enough to command premium prices from paper manufacturers and particle board producers. NTHE Mellott Extra Heavy Drop Belt with pan-type cant lift represents another marvel of mechanical engineering. When logs are processed through the head saw, they're cut into cants, large rectangular pieces that will be further processed into dimensional lumber. This system catches these heavy cants, some weighing over 1,000 pounds, and lifts them precisely into position for the next cutting operation. NTHE pan-type design distributes the weight of these heavy cants evenly across the belt, preventing damage to both the product and the equipment. The lift mechanism operates with hydraulic precision, raising cants exactly to the height needed for the resaw operation. This timing is critical. Any delay here would create a bottleneck that could slow down the entire production line. NTHE Mellott Resaw Runaround System, with its heavy 81XH timber deck, is where rough cants are transformed into the precise dimensional lumber we all recognize. The sequencing stops you see are computer-controlled, positioning each cant exactly where it needs to be for optimal cutting. Those 10-inch roll cases, the cylindrical rollers that move the lumber along, are precisely calibrated to handle different weights and sizes of lumber without causing damage. What's particularly impressive about the H78 RT 81XH transfers is their ability to redirect lumber to different processing paths without stopping the main production flow. Some pieces might go directly to the grading line, while others need additional processing. These transfer systems make those routing decisions automatically, based on the specifications programmed for each piece. NTHE Mellott Sawyer's cab, with dual captain's chairs and joystick controls, might look like something from a modern aircraft cockpit, and in many ways, it operates with similar precision. The Sawyer, the skilled operator who controls the cutting operations, sits in an ergonomically designed environment with complete visibility of the entire cutting process. NT-hose joystick controls allow for incredibly precise movements, with the Sawyer able to position logs and make cutting decisions with millimeter accuracy. The dual chair setup allows for operator training and ensures that operations can continue seamlessly during shift changes. Modern Sawyers require extensive training, typically 6 months to a year, to master these sophisticated control systems. In the 1940s and 50s, A head sawyer was considered the aristocrat of the sawmill. These men earned wages comparable to skilled machinists and often stayed with one mill for their entire careers. The old-style sawyer's tools were surprisingly simple: a cant hook for turning logs, chalk for marking cuts, and an intimate knowledge of wood grain patterns passed down through generations. Today's sawyer cab is equipped with computer screens that display the internal structure of each log, but the final cutting decisions still rely on human judgment about grain patterns, stress characteristics, and market demands. The joystick control system you see here was adapted from military aircraft technology. The same precision control systems that allowed fighter pilots to make split-second maneuvers now enable sawyers to position multi-ton logs with surgical precision. NTHE Mellott transfer to unscrambler feeding the grading line is where individual boards are separated and organized for quality evaluation. The unscrambler, that rotating mechanism you see, takes stacks of boards and spreads them out in a single layer, allowing each piece to be individually graded and sorted. Finally, the Mellott waste removal systems ensure that nothing valuable is lost in the process. Wood chips are collected for paper production or biomass fuel, sawdust is gathered for various wood products, and even the smallest particles are captured for use in manufactured wood products. NTHE finished lumber you see being stacked represents the culmination of this entire process. Each board has been precisely cut, graded, and sorted. The forklift operators loading these boards onto trucks are handling lumber that meets exact specifications for strength, appearance, and moisture content. It's a remarkable transformation from the raw logs that entered this facility just hours earlier. Here in Wahlbach, the Diehl sawmill represents generations of German engineering excellence applied to wood processing. What makes this facility particularly interesting is how it combines traditional European sawmill practices with modern technology to produce some of the highest quality lumber in the world. NTHE Diehl operation specializes in processing European hardwoods and softwoods, with a particular focus on producing lumber for high-end construction and furniture manufacturing. The precision required for these markets is extraordinary. We're talking about tolerances measured in fractions of millimeters. NTHE primary breakdown system here uses a combination of bandsaws and circular saws that would make American sawmill operators take notice. The main bandsaw, that massive blade you see cutting through the logs, is nearly 20 feet in diameter, with teeth that are individually set and sharpened to exacting specifications. The blade moves at approximately 3,000 feet per minute, but the feed rate is carefully controlled to ensure each cut is perfectly smooth. NTHE German approach to sawmill engineering represents centuries of accumulated wisdom about working with wood. The guild system that dominated German crafts from the Middle Ages through the 19th century created a culture of precision and quality that still influences manufacturing today. German sawmill equipment manufacturers like Ester, Link, and EWD have been perfecting their craft for over 150 years, with some companies tracing their origins back to the 1800s, when steam-powered sawmills first appeared in the Black Forest region. What makes German bandsaws unique is their approach to blade metallurgy. The steel used in these blades contains precise amounts of carbon, chromium, and vanadium that are carefully controlled during the forging process. The tooth geometry, the angle, spacing, and sharpness of each cutting edge, is calculated using mathematical formulas that consider wood density, cutting speed, and feed rates. German sawmill workers traditionally completed 7-year apprenticeships that included not just machine operation, but also metallurgy, wood science, and precision measurement techniques. This tradition of comprehensive training explains why German sawmills consistently achieve some of the highest recovery rates in the world, often extracting 5 to 8% more usable lumber from each log compared to conventional operations. What's particularly impressive about the Diehl system is their log optimization technology. Before each log is cut, it's scanned by laser systems that create a 3-dimensional model of the interior. This scanning reveals not just the obvious external characteristics, but also internal features like knot patterns, grain direction, and density variations. NTHE Computer then calculates the optimal cutting pattern for each individual log. This isn't just about maximizing board feet, it's about maximizing the value of each cut. A log that might yield 300 board feet of construction-grade lumber might be worth twice as much if it's cut to produce 200 board feet of appearance-grade material plus 100 board feet of lower-grade lumber. NTHE Cant processing system at Diehl uses a series of gang saws, multiple blades mounted on a single frame that can make several parallel cuts simultaneously. This is where the real precision becomes evident. Each blade must be aligned to within 0.1 millimeters, and they must maintain that precision throughout the cutting cycle. The machinery that accomplishes this represents some of the finest mechanical engineering in the world. NTHE edging operation, where the rough edges of boards are trimmed to create straight, parallel sides, uses optimizing edgers that scan each board and determine the best way to maximize its value. Some boards might yield one wide board, while others are better processed into two narrower pieces. These decisions are made automatically, but they're based on market demands and pricing that's updated daily /N. The European lumber grading standards used at Diehl are actually more stringent than American standards in many categories. For example, European construction grade lumber allows a maximum of 15% knot coverage, while similar American grades allow up to 25%. This attention to quality reflects the European construction industry's emphasis on appearance and longevity. Buildings in Germany often last 200 to 300 years, so the lumber used in construction must meet standards that ensure both structural integrity and aesthetic appeal over centuries of use. The edging saws themselves use stellite-tipped teeth, a cobalt-chromium alloy originally developed for aerospace applications that can maintain their sharpness through thousands of cuts, while producing surfaces smooth enough for high-end applications. NTHE grading system at Diehl reflects European standards that are often more stringent than their American counterparts. Each board is evaluated not just for structural properties, but also for appearance characteristics that matter in high-end applications. Grain patterns, color uniformity, and surface characteristics are all carefully evaluated. NTHE drying operation here is particularly sophisticated. Rather than the traditional kiln drying methods used in many American mills, Diehl uses a combination of air drying and controlled kiln drying that preserves the wood's natural characteristics while achieving the precise moisture content required for different applications. NTHE final sorting and packaging system organizes lumber by grade, species, and dimensions with remarkable precision. Each stack is labeled with detailed information about the wood's characteristics, drying history, and intended applications. This level of traceability is increasingly important in global markets, where customers demand detailed documentation of wood products, origins, and processing history. What's striking about the Diehl operation is how it demonstrates that traditional sawmilling craftsmanship can be enhanced, rather than replaced, by modern technology. The fundamental understanding of wood characteristics and cutting techniques that German sawmill workers have developed over centuries is now supported by precision equipment that can execute those techniques with unprecedented accuracy and consistency. Entenagine. High in the mountains of France's Allier region, the Mondière brothers sawmill represents a perfect example of how geography, expertise, and modern equipment combine to produce exceptional lumber. This facility specializes in processing the softwood species that thrive in this mountainous terrain: Douglas fir, Scots pine, and various species of spruce. What makes this location special isn't just the spectacular mountain scenery. The climate and growing conditions here produce softwood lumber with characteristics that are prized throughout Europe. The slow growth rates caused by the harsh mountain winters create dense, strong wood with tight grain patterns that are perfect for high-stress applications. NTHE Mondière brothers have been in the lumber business for over 3 generations, and their expertise shows in every aspect of their operation. They understand that Douglas fir grown at 3,000 feet elevation has different characteristics than the same species grown at sea level. This knowledge influences every decision, from how logs are stored and processed to how the finished lumber is graded and marketed. NTHE processing equipment here is scaled appropriately for the operation, but it incorporates the same precision engineering principles we've seen in larger facilities. The head rig, the primary saw that makes the first cuts, is designed to handle the typically smaller diameter logs that come from mountain forests, but it maintains the same level of precision you'd find in much larger operations. NTHE lumber grading system pays particular attention to the characteristics that make mountain-grown softwood valuable. Knot size and distribution, grain angle, and density are all carefully evaluated. The slow growth conditions that create these desirable characteristics also mean that each log represents years or even decades of growth, making careful processing essential to maximize value. NTHE finished lumber from Mondière brothers finds its way into applications where strength and appearance are both critical, from traditional timber framing to high-end construction projects throughout France and beyond. It's a perfect example of how local expertise, quality raw materials, and appropriate technology can combine to create products that command premium prices in global markets. This represents the essence of what makes wood processing both an industry and a craft. The understanding that every log is unique, every cut matters, and the combination of human expertise and mechanical precision can transform a tree that grew for decades in the mountains into lumber that will serve human needs for generations to come.